Micrometers are one of the most important basic measuring instruments used in industry. Without them, this operator would have had considerable difficulty in achieving the kind of fit he has just produced between these two parts. The ability to measure dimensions accurately to within 0.01 millimeter is essential for precision engineered components and to various other tolerances for general engineering. Micrometers can supply this facility in most cases. Micrometers are made in a wide range of styles and sizes to cater for normal and specialized applications. These are a few of the more common types of instruments used for measuring external and internal dimensions. And here we have some specialized units ranging from depth micrometers, boring bar micrometers, through to special anvil micrometers, including screw thread measuring units. In addition to these, there are also available micrometer heads, which are intended for incorporation in jigs, fixtures, and measuring machines. The larger diameter head gives an increased resolution, making it easier to read fine divisions. The same idea is adopted for machine tool control, and micrometer dials in some form can be seen on just about every metal cutting machine used in industry. Even blind people are catered for with the provision of braille micrometers. All of these instruments and machine controls use the same basic principle of operation. An accurately ground thread of suitable pitch is rotated in a housing and moves one pitch for each revolution. A metric micrometer generally has a 0.5 millimeter pitch screw thread, and therefore the spindle will move 0.5 millimeter for each complete revolution. The sleeve of this micrometer is marked above and below a reference line, with the markings being 1 millimeter apart in each case. However, the lower markings are displaced by 0.5 millimeter. The thimble or dial attached to the spindle is subdivided to indicate parts of a revolution, and in this case 50 equal divisions are marked around the thimble. A movement of one division past the reference line on the micrometer sleeve means that the spindle has moved 1/50th of 1/2 millimeter pitch, which is equal to 1/100th of a millimeter or 0.01 millimeter. The imperial reading micrometer has a 40 threads per inch screw thread and 25 divisions marked around the thimble. Therefore, one division on the thimble represents 1/25th of 1/40th of an inch, which equals 1/1000th of an inch, or 0.001 inches. Other variations occur on machine dials. For example, the screw may have a 2 millimeter pitch and the dial 100 divisions. Again, this gives the value of one dial divisions as 1/100th of 2 millimeters, which equals 0.02 millimeters. Now let's go back to the metric micrometer and see how we obtain a reading. As we said before, the sleeve is graduated in millimeters and 0.5 millimeters. The first step is to count the number of whole millimeters from the 0 to the left of the thimble. In this case, we can see 8. We then look for any further 0.5 millimeter mark which may be between this point and just to the left of the thimble edge. A mark is visible, and this indicates a further 0.5 millimeter which we must add to our whole millimeters. Now look at the thimble markings and read the graduation which coincides with the reference line on the sleeve. Remember that the thimble graduations represent hundredths of a millimeter. 37 appears to line up, and this is also added to our previous reading. The total reading is therefore 8.87 millimeters. We'll try that again with a different setting. Now we can see 17 marks on the sleeve upper scale, and there are no 0.5 millimeter marks next to the thimble edge. The thimble marking which coincides with the reference line is 0.03, and so our total reading is 17.03 millimeters. Try this one yourself. Did you get 12.77 millimeters? If not, then remember to check first whole millimeters, then any half millimeters, and add the thimble reading when you try this next example. The answer is, of course, 9.91 millimeters. There are a number of other important things to know about micrometers, such as developing correct feel and observing proper care and maintenance. This will lead to confidence in the use of this precision instrument.